For part 2, station 1, there's a stack of 5 quarters. You swipe a card very quickly, and you'll notice that it knocks one of the quarters out while the stack remains. If you swipe fast enough with this very narrow card, you can actually go right under the stack without disturbing it very much. Here it is in slow motion. Disturbs the stack a little bit, but it mostly stays put. Only the card that is actually experiencing a force moves. Pause here and write your observations. Now for station 2. In station 2, you put a card on a cup and flick your finger underneath a quarter. You'll notice it drops into the cup. A lot of people think this has to do with gravity. So let's flip the cup upside down and now flip, and it stays on the bottom of the cup. Let's watch again in slow motion. That's station 2. Pause and reflect. At station 3, we have a plastic container full of water. It weighs about 5 pounds. I'm going to snatch this piece of paper very rapidly. You'll notice it doesn't move. Now, a lot of people think it has to do with weight. So let's do that again with an empty plastic container. Very, very light. Weighs almost nothing, really. So let's put it on there and snatch the paper. There you go. Stop and record your observation. I'm going to do it again here in slow motion. You'll notice that the plastic container does move just a little bit because there is a little bit of friction, but mostly it stays put. And now for station 4. Station 4, we're going to do a very similar demonstration, except make it a little more dramatic. We're going to put a 500-gram mass on top of a very narrow top of a gallon jug, snatch the paper, and look what happens. Now let's swap it out for 100 grams, and we'll even go down to 50 grams. Watch this. So even though it weighs 10 times less, it still stays put on top of the jug. Snatch the paper in slow motion. Moves a little bit because of friction, but it mostly stays put. Record your observations. And now for station 5. At station 5, we have a little cart. It's attached to a weight that's going to cause it to accelerate. A little baby doll attached to the cart. I'm going to release the cart and watch what happens when the car crashes. The baby slides forward. Let's watch again. Watch the baby go forward, the baby doll. So now let's try that again, but this time let's strap the baby doll in. So let's put a seat belt on, pull it back, let it accelerate, and the baby doll stays with the car. The car doesn't do so well, but at least the baby doll stays put. And now for station 6, we have 2 marbles of different weights on a tray. Look at it go forward and what happens to the marbles. Look again very, very carefully. Watch this. Are the marbles really moving? Watch again. That's amazing, isn't it? Record your observations for station 6. Station 7, we're going to walk with the tray now with the marbles on it. Now watch, when I start walking, the marbles appear to come backwards, but do they really go backwards, or do I go forward and meet them? And now I'm walking with the tray, and watch when I come to a stop what happens. The marbles roll forward. Record your observations for station 7. For station 8, students were supposed to try to drop the ball on the target as they run past. Now if you watch, these people have practiced a little bit. They have to let the ball go ahead of time. Why is that? Let's watch it again in slow motion from the side. When the ball is released, it keeps moving forward. It's also being pulled down by gravity, and that results in a diagonal path.